Kubernetes secrets are designed to hold things that your pod needs. Things like certificates, passwords, keys, or even the identity of Batman. Now, Kubernetes can encrypt secrets once they're placed inside of the cluster, but it can't encrypt secrets for you when you place them inside of Git. So if you're placing manifests like this one inside of your Git repositories, well, then you can just go straight to jail. Do not pass go, do not collect $200, because that is a serious security issue. But Git is really great at storing and version controlling Kubernetes manifests. So what if we can have our cake and eat it too? So here's how we're going to get Git to hold our secret manifests safely while still keeping things easy to read, and we're going to use 100% free open source tools to do it. The first tool that we're going to use is Age. And Age, of course, is an encryption tool, and what we can use it for right out the bat is to encrypt entire files. And the only means someone may have of reading that file is if they have the appropriate key. But man, that's annoying. The only sensitive part of this manifest is the data that Batman is Bruce Wayne. And with the whole thing encrypted, we can't read diddly squat. But we can limit just the encryption to just that one value by using another tool, SOPS. So to bottom line it, what's happening here is that Age is going to handle the actual encryption, but SOPS is going to make sure that that encryption is limited to just this one value. You can see how that's keeping things safe, but it's still keeping this document readable and usable. So when we've got all of this set up, here's the way that it's going to work. We can still enjoy the version control and storage of GitHub, while sensitive data and only sensitive data is encrypted. And when it's time to build that secret inside of our cluster, we have a key that allows us to decrypt it, sending the plain text to the cluster, but still keeping things encrypted and secure in Git. Let's get this set up. First, let's make a dedicated folder so that all the chaos from this lab can stay in just one place. Now, we want to try and simulate a real GitOps scenario. We're not going to push anything in this lab to any repos online, but we are going to treat this directory like a repo that could be pushed safely. And just so Git doesn't complain when we commit later, we're just going to put some Git configs in there, and now we are good to go. Now, in a moment, we are going to be creating a decrypted secret. Let's make a namespace to put that in and call it GitOps. And what we're about to look at is the decrypted, absolutely do not put this inside of Git at all version of our secret manifest. It is plain text. It is intentionally unsafe. At this point, that is the plan. And per the plan, the name of our secret here is Dark Knight, and the sensitive value is that Batman is actually Bruce Wayne. So if this were to go into a repo as is, Batman would be cooked. Now remember, Age is our lock. It's what does the actual encryption and decryption. And to get this installed, we're going to want to head over to the Age GitHub repo. And what we're going to do is we're going to grab the pre-compiled Linux binary that's already hot to trot and ready to go. So scroll down the side until you get to Releases, open that up. And then you're going to scroll down and right-click the URL for the Linux AMD 6.4 release. I'm going to copy the link address, and we can go ahead and wget that. All right, there it is. We're now going to extract the binaries that are inside of that file, and there are two. One is called Age. The other one is Age Key Gen. One does the encryption, one creates the key that decrypts. You get it. So for that to work, we're going to need to have to move all those directories into our local binary directory here, and that should make sure that they are executable. We can check and make sure by just checking version. Yep, looks good. And how about Age Key Gen? How's that looking? Yep, that's looking good as well. Looks great, and that's good, because now we need two things: a public key to encrypt to, and a private key to decrypt with. And just remember, the private key, hence its name, is the thing you gotta protect like your life depends on it. Batman depends on it. So let's generate our keys, put them inside of a file. We'll call it keys.txt. And if you were to take a peek inside of that file here, there you go. We're going to be popping that public key value that you see there inside of a lot of different places. They're always going to start with age 1. So I'm just going to go ahead, grab that, and pop it inside of a notepad file so that I can refer to it later. All right, looks good. We are now going to encrypt and throw the padlock over this entire secrets.yaml document using age. And what I'm going to show you is what if I stopped after this step. Yeah, I could secure the document, but then the whole document will be encrypted, making it super annoying to review. So we're going to encrypt. That is our public key for recipient. We are going to write our encrypted file to secrets.age, and we are going to be encrypting secrets.yaml. So you can see we did just successfully create that. But when I view the file, such noise! It's secure, but noise! Alright, so before we tackle that issue, let's prove that we can decrypt this back. We're going to use our private key in order to do so. So in order to do that, we're going to use age-decrypt, saying that our private key is inside of that keys.txt file. Remember, we are going to be decrypting our encrypted secrets.age file, and we're going to be decrypting it to secrets decrypted. So we now have two decrypted files here, plain text files, the original secrets.yaml and secrets decrypted.yaml. We could just take a real quick glance at both. Secrets.yaml, there it is, Bruce Wayne. And if we were to check out secrets decrypted.yaml, Bruce Wayne, but you can always be very confident they're identical by just using diff. And as you can see, ain't no diff about it. These files are identical. So yeah, age works. It locks and unlocks, but it locks the whole file, and that's why we need SOPS. Now, if you're not familiar with SOPS, let's just be clear about something. SOPS doesn't invent new encryption. We're still going to be using age for encryption and decryption. But what SOPS does is it lets us encrypt only the values that we care about. And like with age, we're going to need to get this installed. So once again, we're heading to a GitHub repo, this time for SOPS. And once again, we're going down to releases. And we'll find, how lovely. It has all the commands ready to go for us. Download the binary, move it into our local bin directory, and then make sure that it is executable. So I'll just go ahead, copy that, bang that in here. All right, so after we move that to the user bin directory and we gave it execute permission, yep, looks like we got this installed and we are ready to rock. Now, what can get obnoxious about SOPS is that to get it to do what you want, you might have to type a whole bunch of flags with every SOPS command. No thanks. Let's set the rules once inside of a file. Again, inside of our Git directory here. And we're going to make it a hidden file, sops.yaml. And this is what we're going to call on as far as rules every time SOPS does its thing. So path regex is telling us which files are supposed to be managed by SOPS. And what that crazy regex there is saying that any file name that starts with the word secrets may or may not be followed by the word .encrypted and ends in .yaml, that's a file that's managed by SOPS. Age. This line is saying use age to do the locking and then lock it for this specific key. Don't forget, you need to put your actual public key inside of that field. And encrypted regex is saying that any YAML keys that say Batman should have their values, which we know is Bruce Wayne, be encrypted. So that's it. Age does the encryption, but here we're saying SOPS decides what gets encrypted and how. So let's give it a whirl. Let's encrypt our original plain text secrets.yaml file using SOPS and the rules that we just created. So the new file we're making here is secrets.encrypted.yaml. Now once again, we've run encryption, but let's peep the difference between before and now. Nice. Do you see how the contents of the manifest where it matters are encrypted? We can see Batman is our key, but we can't see what his secret identity is, which is great. You'll also see that there is now a SOPS metadata section. That's nice because that records info that's needed for decryption later. So make sure that you leave that in there. So now decryption. We're going to go over two different methods to tell SOPS of Age's private key location so that we can decrypt this sucker. And our first method is going to be to just set an environment variable. So you can see keys.txt. That's the one that had our secret key inside of it, right? We're going to put that inside of a environment variable, the location of keys.txt. Now that we've got that pointing to that file, we can run our SOPS decrypt command. And we're going to take that file that we just made, secrets.encrypted, and we're going to output its decrypted output to secrets.decrypted.yaml. And if we were to check the results of that new file that we just made, we can see that, yep, once again, Batman is billionaire playboy Bruce Wayne. Now, if you are going to be using diff at this point, here's something I want you to be careful of. If I were to diff the original plain text manifest, secrets.yaml, against the manifest that I made just now, secrets.decrypted.yaml, you're actually seeing some output. But what's different, really? Look. Do you see that, oh, the indentation is not exactly the same as the original, That's okay. SOPS will keep your data consistent, but it can rewrite things like formatting and indentation. And the difference that you're seeing here is purely cosmetic formatting issues, and it's not an issue at all. Now, if an environment variable doesn't float your boat, let's try a different method to point at that key location. So let's unset that environment variable that we just made. And instead, we're going to put that keys.txt file in the default path that SOPS is going to automatically look for. So in our repo, that's .config SOPS age. And what we'll do is that we will move keys.txt into that directory. Now, once again, we're going to run a decrypt, but this time without an environment variable. And once again, this is going to overwrite the original secrets.decrypted.yaml file. And once again, if I run the diff on the original versus the newly decrypted file, once again, you see that it's just that cosmetic indentation changes. And if you really wanted to see what it looked like, the same, it just looks the same. So great, this works both ways. Now, since the file is decrypted, then that means that we can actually apply this to our cluster. As you can see, this is my machine that has kube control access. Let's go ahead and apply that decrypted manifest, and then let's verify that it does exist. Awesome. So we can store the encrypted file on Git. And when it comes time to create the secret, we can decrypt and then apply the secret to Kubernetes whenever we need to build this script again. But we're not done here, because it would be way too stinking easy at this point to commit an unforgivable sin. We have all of these plain text manifests that could get committed to our repo. So before we can say we're done with this, we need to put some safeguards in place to teach Git to never track plain text secrets, to never track decrypted output, and to never track private keys. So we're going to make a git ignore to make sure that that happens. And we're going to keep it stupid simple here. Basically, all of our files, secrets, followed by any characters.yaml, as well as, of course, keys.txt, which has our private key inside of it, we will make an exception for our encrypted file, secrets.encrypted.yaml. So let's test it. We'll run a git add against all of our repos, files, and directories, and if we did our job correctly, we shouldn't see that any of our sensitive files are going to be committed, and they are not. Just remember that SOPS.yaml are just our rules for how SOPS works. It does include our public key, but that's okay. Secrets.encrypted.yaml is, well, encrypted. And what we don't see are any of our plain text files or our keys.txt file with our private key inside of it. So at this point, we could confidently commit and we're ready to rock. So that's the pattern. Git keeps your secrets safe, Kubernetes gets what it needs, and your secrets aren't posted on the front page of the internet. Age is what handles the lock, and SOPS is decide what gets locked. If you like this walkthrough and you want to see more just like it, then click the link down in the description for more great Kubernetes training. I thank you, Alta3 thanks you, and most importantly, Batman thanks you.